Hello everybody. Today we're looking at some 2-point review. This is the homework that's before test 6. So let's get right into it. We're starting, this is going to cover sections 2.6, 2.7, and 2.8. So we're starting at number 68. So we're going to start with these transformations first here in 68. And we're starting with the parent function of x squared. And if I wanted to shift x squared 5 units to the left, I would replace x with x plus 5. And then it says reflect across the y-axis. So I'm going to change that x with a negative x. And then it says shift down 2 units. So in order, I'm going to put the plus 5 on the inside. That's going to shift left 5 units. I'm going to change the x with a negative x. That reflects across the y-axis. And then I'm going to move down 2. And if I was looking at that at decimals, start with y equals x squared. Okay, so if I do the plus 5 first, again, shift left 5 units. That point is now at 5, 0. So again, x squared starts at 0, 0. X plus 5 is going to shift left. And then if I reflect it, check this out. If I do that second, bam, it's going to reflect over the y-axis. So change, and I'm doing that second. So first shift left, it brings it all the way left. And then I reflect it, it brings it all the way right. And then I'm going to go down 2 units. So on the outside, minus 2. And there's my final answer there. So that vertex went from 0, 0 to negative 5, 0 to 5, 0 to 5, negative 2. That's that first one. Okay, 69. So we're going to use translations here and everything. So absolute value of x, and then absolute value of x minus 2 is going to go down 2 units. So absolute value of x is my v, and then when I do minus 2, oh shoot, not down the inside, sorry, absolute of x minus 2, it's going to go down 2 units. That's 70. Root x plus 1. So what's that going to do? Well, root x is this one here, 0, 0, 1, 1. So I can get this. 0, 0, 1, 1, 4, 2. If I did that square root of x plus 1, that's going to go up 1 unit on the y values for each of those points. 71, just x minus 2 squared, that's going to be a shift right. So x squared and then shift right units. And we looked at an x squared already up here, so I'm not going to do that one again. Okay, let's look at a cube root. So cube root of x, 0, 0, 1, 1, 8, 2, negative 1, negative 1, negative 8, negative 2. There's the cube root of x. And on the inside, I'm going to do cube root of x plus 1. So that's a shift left of 1 unit. The point that was at 0, 0 is now negative 1, 0. Subtract 1 from all of the x values. Again, that one on the calculator is going to be math. And then there's cube root right there. Cube root of x plus 1. Do a zoom, 6, and there we go. Okay. Let's check this next one here. Okay, so now we're going to do off of some generic functions here. So let's look at this 79. So I'm given this generic graph here. So I'm going to keep track of the point negative 4, negative 2, 0, 2, 2, 2, and 4, 0. Those are those 4 corner points for that blue graph. Okay, so if I'm going to do in 79 f of 2x, I'm going to half all of these x values so that when I do double them, I get this x value to get this y value. Again, this is what the function knows. If you give it a negative 4, it's going to give you a negative 2. Now, if you put in a negative 2 times 2 is negative 4 to help with the negative 2. That's going to be a horizontal shrink of a factor of half. 81. So negative f of x plus 1 minus 3. Let's keep track of these 4 points. Always do your horizontal shifts first. Always do your vertical shifts last. So first thing I'm going to do is I'm going to take all these x values and take one away from all of these x values. Bam, there we go. Then I'm going to take all these y values and multiply all of them by negative 1. There we go here. Final move, always do my vertical shifts last. I'm going to take these y values and I'm going to subtract 3 from each of them to get these values here. So my new points are negative 5, negative 1, right there. Negative 1, negative 5, right there. 1, negative 5, right there. And then 3, negative 3, right there. Again, my transformations in order are shift left, change the sign of the y, reflect over the x-axis, and then down 3. That's 81. Let's check out 89. Okay, so now we're switching to section 2.7. And I want to know if this function is even, odd, or neither. Well, how you choose is if you replace x with negative x, you create the f of negative x function. And then if everything changes sign, if f of negative x is equal to the negative f of x, that's odd. So in 89, that's actually what's going to happen in this case. Because if I put a negative x in here into negative 4x cubed plus x, that negative x cubed is going to be negative on the outside. So negative negative is positive 4x cubed. And then plus a negative x is just minus x. So if you notice, both things change sign. I can factor a negative 1 out. And so f of negative x is the negative of, this is the original function. F of negative x equals the negative of the f of x, proving that that is an odd function, symmetric about the origin. Let's look at 91. P of negative x is equal to square root of 4 minus negative x squared. But if you square that negative x, it just keeps its same sign. So this is the exact same original function. So P of negative x equals P of x, proving that's an even function, symmetric about the y-axis. And let's look at this one here. Square root 4 minus x squared. Yeah, symmetric about the y-axis. There's that one there. The previous one was negative 4x cubed plus x. That's 70. Negative 4x cubed plus x. Let's take a look at that one. Negative 4x cubed plus x. So here's that symmetry. So if you look at these points here, you change the sign of the x, you change the sign of the y. So I'm seeing that symmetry there. So this is an odd function, symmetric about the origin. F of negative x equals the negative of the f of x. Okay, let's go on to 95. A little jump here. Okay, 95, I'm given a piecewise function and I'm looking for certain values. So in part A in 95, I want to know f of negative 4. Okay, so there's 3 different rules that I'm looking at in problem 95. So for x values less than negative 1, I'm following rule 1. For values of x greater than or equal to negative 1 or less than or equal to 2, I'm going to follow rule 2, the x squared. And for x values greater than 2, it's just going to equal to 5. So remember, this is one function. So the x value can only go to one place. Otherwise, it wouldn't be a function. It'd fail the vertical line test. So if I put in a negative 4, I follow the first rule. So I'm going to do negative 4 times negative 4 is 16 plus 2 is 18. If I plug in a negative 1, that's the second rule. That's negative 1 squared is positive 1. If I plug in a 3, I'm going to follow the third rule. So that's just the phi function, so that's just going to equal 5. Let's come back to 2. So the 2 is back at the second rule because that's x less than or equal to 2. So 2 squared equals 4. So again, you have to figure out what rule that x value is going to follow. It only follows one rule because it's still a function. All right, let's look at 97. In 97, we actually want to graph this piecewise function. So do the opposite here. Okay, so absolute value of x. So this is the absolute value of x. It's that v graph again. But I don't want the entire absolute value of x. I just want absolute value of x for x values less than or equal to 2. So I'm going to erase everything over here that would be on the absolute value of x. So it's just this part here, stopping there. Closed circle right there. Then I'm going to graph the 2 line. Well, 2 is a horizontal line. It runs like that for x values greater than 2. So at that same spot, it's almost like one thing is an open circle and one's a closed circle. So it connects like a train right there. So that's going to be a nice continuous function right there. So this piecewise is a continuous function. That's the graph for problem 97. Okay, so 99, this is that greatest integer function again. And this one, again, I'm going to show you on the TI. So let's flip this over here so we can look at both together. Okay, so I'm going to put in greatest integer function. So that's under math and then num. And again, that's where absolute value is. And then greatest integer is down here at number 5 of x. Close that up. And then let's graph that. This is the step function. The goofy bracket means greatest integer. So that's where it's like, if you look at a table, I'm going to change my table to count by 0.2s. And go to the graph again. So all these values, the y values are 0 until you get to 1, and then it's 1. And then it stays as a y value of 1 until you get to 2, and then it jumps to 2. So you're going to have these open circle, closed circle, open circle, closed circle, open circle little steps. It's called the step function. So what I want to do is, what are these different values? So what is the greatest previous integer for all of these values? So this one is greatest integer of x minus 1. So let's put that in. Absolute value of x minus 1. So here's this one here. It's a little shifted here. Okay, so if I put in negative 1.5, minus 1.5 minus 1 is minus 2.5. So think left. So like, what's the greatest previous integer on the left side? That would be negative 3. If I did that on my solver screen, alpha trace y1, alpha trace y1 of negative 1.5, and that's negative 3. It's the greatest previous integer that it passed. For b, if I put in negative 2, minus 2 minus 1 is minus 3. That is also minus 3. What about 0.1? 0.1 minus 1, that's negative 0.9. So that's still at the negative 1. So let's check that one again too. So that's 0.1. So minus 1. Yep. So because 0.1 minus 1, that's minus 0.9, so it's going to be the left of that. 6.3. 6.3 minus 1 is 5.3. What's that greatest previous integer? It's 5. So again, practicing a new function called the greatest integer function. Okay, 101. Okay, we're looking at a parabola graph here, and we know the intervals of increasing, decreasing, and constant. Okay, so it's not constant because it has to be on an interval, and the turning points don't count as constant, so nothing there. And again, as you're looking at the parabola, this parabola from left to right goes down and then up. Again, some people will look at that parabola in 101 and be like, oh, look, it's always increasing, increasing, increasing. But really what we mean is, as you go from left to right, if you're riding like a little roller coaster, this parabola goes down and then it goes up, decreasing and then increasing. So the decreasing interval is that negative infinity to 2. And we do parentheses in our book, so I'm going to keep that going. And then increasing from 2 to infinity. Let's go to 105. Okay, so now we're doing some function arithmetic. So if you want f minus h of 2, that's the same as f of 2 minus h of 2. So f of 2 is going to be minus 6, and then h of 2 is going to be 1/3. So 1/3 plus minus 6 is going to be, that's going to be minus the 1/3. So minus 6 is the same as minus 18/3. Minus 1/3 is minus 19/3. F minus h. Check 108. Okay, so fog of 5, f of g of 5. So 5 goes into the g function, And I get 5 minus 2 is 3. Absolute value of 3 is 3. And then what's f of 3? Well, that's negative 3 times that 3 is negative 9. Okay, 110. Okay, this is one of those graphs. So let's see if we can keep track of all this stuff. So in your book, the F graph is in pink and the blue graph is in blue. So F plus G of 2 is the same as F of 2 plus G of 2. F of 2 is equal to 3 plus G of 2 is negative 2. 3 minus 2 is 1. Closed dot means multiplication. So G of negative 4 times F of negative 4. So G of negative 4 is equal to 2. F of negative 4 is equal to negative 1. 2 times negative 1 is negative 2. Part C. G divided by F of negative 3. So that's the same as G of negative 3 divided by F of negative 3. G of negative 3 is equal to 1. 1 divided by F of negative 3 is 0. 1 divided by 0, undefined. F of G of negative 4 in part D. Well, G of negative 4 is equal to 2. And then F of 2 is equal to 3. There it is right there. All right, let's go to E. G of F of E should be G of F of negative 4. I think that's an open circle. It might not look like it there. So negative 4 goes into F. So negative 4 goes into F, and I have a 2. So F goes in, negative 4 goes into F, and I have a 2. And then negative 2 goes into G, and I get a 1. So this one should be 1. So that should be that just changed that number there. So negative 4 goes into F, and I get 2. Then G of 2 is negative 2 for that one right there. So I got to change that later for you. So F. G of F of 5. So I'm going to put a 5 into the F function. So 5 in the F, you can't do that. That's undefined. Okay, let's go to 118. Make sure this is all good. Negative 4. Oh, I'm sorry, this is right. I just flipped the things up. Sorry, team. So negative 4 goes into F, that's the pink function. Negative 4 goes into F, that is negative 1. And then G of negative 1 is equal to 1. Sorry, that one's all good. Okay, 118. So I'm going to do a difference quotient. So first, I need to do what is f of x plus h. So the f of x plus h is going to equal, well, the f function itself is 3x squared minus 4x plus 9. So if I put an x plus h in there, it's going to be 3x plus h squared minus 4 times x plus h plus 9. Let's FOIL this out. This x plus h squared is going to be x squared plus 2xh plus h squared. Now I'm going to multiply all of that by 3. So that's going to be 3x squared plus 6xh plus 3h squared. That is that right there. Distribute the minus 4 to both terms. Minus 4x minus 4h. And then add the plus 9. Now don't forget after that, I have to minus the entire f of x. So it's going to be minus 3x squared plus 4x minus 9. Distributing that distributing that negative to the entire f of x function. So these cancel out. 3x squared minus 3x squared, that's gone. Minus 4x plus 4x, that's gone. 9 minus 9, that's gone. So I'm just left with 6xh plus 3h squared minus 4h. And that's all over h. Factor and cancel that h out, and I get 6x plus 3h minus 4. Well, that's all our problems today. Good luck on that test. Take care, everybody.